So this time it's changed slightly different. You're given all of the data here and you're given a rate equation now. So you're not actually asked to work out the rate equation. You're given the rate equation here and all of the data, and you've got to calculate one of the missing parts in the table. So now it's almost turned on its head. You've been given the rate equation, you've been given this data here, and you've got to work out this missing part here. So let's have a look. Let's do spoilers again. So in experiment 4, where there's data for both concentrations and the rate. So we've got everything in experiment 4. So if we've got everything in experiment 4 here, we've got the rate, 7.2 times 10 to the minus 4. We've not got the rate constant, K. We've got C, the concentration of C, so we can work out C squared, and we've got the concentration of D. We've got everything in that equation apart from the rate constant here. So we put these numbers in, and we can work out the rate constant here. So rate equals the rate constant C squared multiplied by D. The rate in experiment 4, where we've got a complete set of data, is 0.0072 or 7.2 times 10 to the minus 4 equals the rate constant multiplied by 1.9 times 10 to the minus 2 squared, because C squared, here you've got C squared, so you've got the concentration of C, 1.9 times 10 to the minus 2, and it's squared, multiplied by the concentration of D, which is 3.5 times 10 to the minus 2. So you calculate those, so I would always work these out first, and therefore you get 0.00072 equals K multiplied by 0.000162. You divide this by this, and K therefore equals 57. So we've worked out K for one of the sets of data. Now if it says a constant temperature, the only thing that will change K, the rate constant, is temperature. So if temperature stays the same, then K stays the same. K is only changed by temperature. Nothing else can change it. So if we've got a constant temperature, we know that K must be staying the same. So if K stayed the same in experiment 5, therefore we can work out, it just wants us to work out K. It actually doesn't want out to be calculated here. I think that would be the next bit of the question. It wants us to use K, which we've done, and it wants the units of K. So what we do then is, rate is moles divided by decimeter cubed divided by seconds. That's always the case. Mole decimeter cubed divided by decimeter cubed seconds is given here, equals K. We don't know the units of K, and we've got a concentration squared, so we've got a mole divided by a decimeter cubed, mole divided by a decimeter cubed, and another concentration here, mole divided by a decimeter cubed here. So what you can do therefore is 3 decimeter cubes on the bottom on this side become 3 decimeter cubed on the top. So if you take them across the equal sign, they come to the top. So I've got mole, and I've got 3 decimeter cubed on the top on the other side, and I've got mole on this side on the top. If they go across the equal sign, they go to the bottom, and they've gone on the bottom. Now I can cancel, so I can cancel a mole on the top and a mole on the bottom. I can cancel a decimeter cubed on the top and a decimeter cubed on the bottom, which will leave me 2 decimeter cubes on the top, and it will leave me a second still on the bottom, and a mole on the bottom. So now what I do then is I take mole and mole go up to the top, and a second goes up to the top. If they go up to the top, they become -1, so that becomes S to the -1, mole to the -1, and mole to the -1. And then you add the 3 and the 3 becomes a 6. The S to the -1 just stays the same, and a mole -1 on the top becomes a mole -2. So that's your units of K. I think the next question will probably be to work out to be calculated here. Calculate a value for the initial rate in experiment 5. Indeed it is. So let's have a look at that. So we've got rate equals K multiplied by C squared multiplied by the concentration of D. We know K has not changed because the temperature has stayed the same. It's a constant temperature, and there's only temperature that would change K, so if that's staying the same, it's going to stay the same. And then we put the numbers in. From here, 3.6 times 10 to the -2 is the concentration of C squared, so that needs squaring, multiplied by 5.4 times 10 to the -2 concentration of D. There, and we run it all out, and the rate equals 0.00399, and we've been given the unit, so that's fine.